Welcome to The Explainer. Today, we're going to dig into a question that we all think we know the answer to. Something we probably learned in, elementary school? I mean, it seems super simple, right? Hot air rises. It's why a campfire's heat goes up, why hot air balloons float. But what if that simple reason we've all been taught isn't the real story? What if there's more to it? You know the textbook answer. Hot air is less dense, so it floats up. But the source we're looking at today claims that's just a description of what happens, not the actual physical force that's making it happen. So yeah, what is really going on here? Okay, so our source for this explainer, an article by an author named Miles Mathis. It starts in a really interesting place. It dives into a top-ranking online physics forum to see how the experts, the people who are supposed to know this stuff, publicly answer this very question. And boom, right away, a user named Troot gives the classic answer. Hot air's less dense, so it gets a buoyant force pushing it up. It's just like an air bubble rising in water. Simple. Case closed, right? Well, not so fast. Because immediately, another user, Quarto de Seaman, jumps in and pokes a pretty big hole in that idea. They ask, wait a minute, don't gases at different temperatures usually just mix together? They diffuse until everything's the same temperature. So why doesn't the hot air just blend in with the cold air around it? And this one, simple question, it just kicks off this whole debate. And according to our source, this is where you start to see some serious cracks in that standard model we all learned back in science class. So another user, Crab, tries to shut it down. They jump in to defend the textbook answer, basically just repeating the core idea from fluid dynamics. Less dense things float on top of denser things. That's it. End of story. But Quartodeciman isn't letting it go. They press the point, and it's a good one. They're like, okay, let's think about this on a molecular level. Hot air just means the molecules are more spread out. So what's actually stopping the colder, denser molecules from just falling down into the gaps between the hot ones? Why don't they just mix instead of the hot air rising up in a big column? And this is where it gets really interesting. This is the moment the whole explanation just hits a brick wall. Another user basically says, well, fluid dynamics just doesn't work that way. But when they're pushed to explain why, crickets. They've got nothing. The standard model is great at describing what happens, but it really struggles to explain the fundamental mechanical reason why it happens. So this is where our source material makes a pretty big pivot. The author, Mathis, he argues that the reason everyone on the forum is stuck is because the problem isn't really about fluid dynamics at all. The real issue, he claims, is way deeper. It's about how we understand gravity itself. Okay, so check this out. Here's the core of the problem. Physics 101 tells us that gravity acts on mass, the amount of stuff in an object, not on its density. Now, when you heat up air, it expands, but its mass doesn't change one bit. So its weight shouldn't change either. If gravity is pulling down on it with the exact same force, why on earth would it suddenly start rising? So now that he's laid out all the problems with the standard explanation, the source proposes something completely different. It's a pretty radical new mechanism to explain what's actually going on. He calls it the charge field. The theory is that it's a constant, upward-flowing stream of tiny particles, photons actually, that are radiating up from the Earth's surface. So get this. Instead of just thinking about gravity as a pull from above, this theory suggests there's also a constant physical push coming up from below. And here's how it would supposedly work. You heat up a bunch of air. It expands, right? It takes up more space. Well, this larger volume now presents a bigger target for all those photons streaming up from the charge field. More photons hit it, which means it gets a bigger physical push from below, and up it goes. This just completely reframes the whole thing. It's not about some passive idea of floating just because of a property called density. No, this theory says it's an active mechanical push. A larger object literally gets pushed upward with more force than a smaller object, even if they have the exact same mass. And the author argues this theory does more than just solve the hot air riddle. If it's true, it could actually help explain some other pretty big, long-standing mysteries in physics too. Now, of course, the big question is, if this field is real, why haven't we measured it? Well, the source has an answer for that. It argues that scientists have probably been looking for the wrong thing. They're always searching for a standard electromagnetic field, an EM field, but this theory suggests the charge field can exist without an EM field.
So just because we don't find that EM signature, it doesn't mean the charge field isn't there. It just means there aren't any charged particles or ions in that specific spot.
But the implications here get even bigger than just lift. The source argues that this charge field might also solve another huge mystery. How in the world does our atmosphere hold on to its energy and stay so stable? I mean, think about it. Our atmosphere is just trillions upon trillions of molecules all bouncing off each other. Now, in the real world, those collisions aren't perfect. A tiny bit of energy gets lost every single time. So, over millions of years, you'd expect the whole atmosphere to cool down and basically just collapse. But it doesn't. The source suggests this charge field is the reason why. It's like a constant propellant from below, always bombarding the molecules, giving them back the energy they lose in collisions, and keeping the whole system stable and energized. So let's just wrap this all up. The key takeaway from our source material is this. It totally challenges that classic idea that hot air rises just because it's less dense. Instead, it proposes a brand new mechanical reason, a constant physical push from an unseen charge field coming right up from the Earth. And that leaves us with a pretty wild final thought, doesn't it? Are the fundamental forces we all learn about, like gravity, really the whole story? Could there be this invisible, constant push from below that's shaping our world in ways we've never even considered? That's a fascinating idea to chew on.